All right, in this lesson, we're going to go over angle of elevation and depression. And so this is going to just use a lot of what we went over in the previous lesson over our trigonometry. It's just going to apply it to word problems. Okay, so we have our angle of elevation and depression. All right, so what is angle of elevation and depression? So suppose you are looking up at a plane. The angle formed by a horizontal line and your line of sight to that airplane is called your angle of elevation. Now, suppose you are standing on a cliff and looking down at a river below. The line stretches horizontally from your point of view on a cliff. The angle of sight to the river below forms an angle of depression with the horizontal line. Okay, so key thing is we do have horizontal lines here. And so just a note that your angle of depression and elevation are measured from a horizontal line. Also, they are alternate interior angles, so they are congruent. Because of those parallel lines that you have, the two horizontal lines, and like I said, they are congruent. Okay, so let's look over here just real quickly and just mention a few things. So once again, when it comes to angle of elevation, okay, you are going to start at your horizontal line, and it is the angle that is formed by looking upward from that. Okay, with your angle of depression, you are starting with your horizontal line and then looking downward from that. So noticing that that angle of depression is going to be outside of the triangle that's being formed, and that's okay. You can draw your own triangle over here if you wanted to from that angle, but you can also then just move it into the angle of elevation, which is what I usually do. All right, so let's look at our 4 problems for this lesson. Okay, so we have at a certain time of day, the angle of elevation of the sun is 44 degrees. Okay, so real quick, what I like to do to start these problems is I am going to draw a right triangle because we'll always be dealing with right triangles. So I'm going to start with that. Okay, it's not perfect, but you get the idea. And so once again, they did tell me my angle of elevation, so looking upward, is 44 degrees. And then they tell me that we are finding the length of the shadow cast by a building that is 30 meters high. Okay, so we have a building here that's 30 meters high. And we are going to find the length of my shadow, so I'm going to call that X. Once you have labeled your picture, you're going to go about it like we did in the previous lesson. We're going to start off by marking my angle, labeling my opposite, my hypotenuse, and my adjacent. Okay, once you've done that, you can see here that you know your opposite. You are finding your adjacent. That is going to be our tangent. So tangent of theta, 44 degrees, is equal to my opposite, 30, over my adjacent, x. Okay, so once again, we still always need to see our trig ratio equation. That's what this is. And then if you remember from our previous lesson, there was that quick shortcut you could do here where when you are solving and your x is in the denominator, you can switch that with your trig function. So x is going to be equal to that 30 divided by my tangent of 44 degrees. And we're going to include our units here, so we're going to put our meters here. So this would be my calculator ready form answer. And then just, getting that practice of rounding. I'm going to, once again, like we did in the previous lesson, let's round to the nearest hundredth. So I'm going to plug into my calculator here. We have 30 divided by tangent of 44. Remember, make sure your calculator is in degree mode, and you are going to get 31.07 meters. All right, now let's move into number 2. Okay, number 2 can be a little confusing. We have a lighthouse is 100 feet tall. So once again, I'm going to start off by just drawing a right triangle. Okay, so my lighthouse is 100 feet tall. The angle of depression from the top of the lighthouse to one boat is 24 degrees. Okay, so one boat, I'm going to draw a little boat here, and our angle of depression to that boat is 24 degrees. Like I said, I do like to use that as my angle of elevation, so I'm going to go ahead and move it down. Now they're telling me the angle of depression to another boat is 30 degrees, okay? So I'm going to move that line inward some, because in order for this angle of depression to be larger, it's going to be closer to the boat. So this angle is now 31 degrees. So I'm going to label it down here as well. I'm going to, just for the fun of it, draw a cute little boat there too. We want to know how far apart are the boats. Okay, so I'm finding this length here between my two boats. Well, in order to do that, I need to focus on right triangles. Okay, and so what I can do is I can solve for the entire length. We'll call that y. And I can then subtract the length to that second boat there, my z, from it to figure out how far apart those two are. Okay, so that's what we're going to do. So I'm going to start off, and it doesn't matter which one you start with. I'm going to start with solving for my y. So I'm going to circle my angle. I'm going to label my opposite, hypotenuse, and adjacent. Okay, and so I'm solving for my y once again. So based off what I have here, I'm going to be using tangent of my theta, 24 degrees, is equal to my opposite, 100 feet, over my adjacent, which is that y. Okay, once again, what I'm solving for is in the denominator, so I can just real quickly switch my trig function with that y, and I get that y is equal to 100 divided by the tangent of 24 degrees. And you can put your units here, but it's not my final answer, so I'm going to hold off. I'm going to now move into solving for my z. Okay, so z is going to be using this angle here, okay? And so I'm going to label, we've got same opposite. We have our hypotenuse moving inward. And then my adjacent is that z. So once again, based off of what I have here and what I'm trying to find, I am going to be using tangent again of 31 degrees this time is equal to my opposite, 100, divided by my adjacent, which is that z. So quick way of solving for my z here, I'm going to switch it with my denominator and the trig function to get 100 divided by tangent of 31 degrees. All right, so to solve for my x, okay, my x is going to be equal to, we're going to find our y, take that y length, 100 divided by tangent of 24 degrees. And we are going to subtract from it my z. So making sure that you are starting from the whole and subtracting the smaller part, we'll have our tangent of 31 degrees. Okay, so we are measuring in feet here, so I'm going to put that at the end for my units. And this would be my answer for that x. And the one thing I do want to mention, I'm going to plug this into a calculator once again, but the one thing I want to mention here is, especially with you doing your homework, to make sure we have our most accurate answer, we do want to type into the calculator exactly what you see here, that 100 divided by tangent of 24 minus 100 divided by tangent of 31. Because if you do not, and so we're going to get 58.18 feet. But if you don't, you run the risk of having a rounding error, because if you round the first and the second separately and then subtract them, it might not come out to be the exact answer that we're looking for in your homework. So just input the entire thing into the calculator at once. All right, now let's move into number 3. So in number 3, once again, I'm going to start off with my right triangle here. And we have at an altitude of 760 feet. So altitude is your perpendicular height. So I'm going to label that right here. The engines of a plane suddenly fail. Find theta, which will be your angle of glide, needed to reach a clear field 5,000 feet away. So angle of glide is the same thing as angle of depression. Okay, so I'm going to place that right here. This is my theta. This is what I'm looking for. Except for we just use the term angle of glide when we're referring to our, planes, our aircrafts. Okay, so same thing as angle of depression, which, like I said, I love to just use that as my angle of elevation. And so I'm going to move that down there. And then it's telling us that the plane is 5,000 feet away from the field. Okay, so in order to be 5,000 feet away, that is going to actually be the hypotenuse length here that I'm labeling. All right, so once we have it labeled, we are going to mark the angle, label my opposite, hypotenuse, and adjacent. Okay, and once I've done that, I can see here that I am going to be using sine. We'll use sine of theta is equal to my opposite divided by my hypotenuse. And remember here, you're going to be using that inverse trig to switch these two so you can solve for that angle. So we've got our inverse sine, and then we got that 760 divided by 5,000 degrees. It's going to be equal to my theta. Okay, and with that being said, let me plug this into my calculator here real quick and see what I get. So we've got inverse sine of 760 divided by 5,000 is going to give me a rounded answer of 8.74 degrees. All right, now let's move into our final problem, we have in the figure on the right, the co-pilot in the airplane is flying at 8,000 feet over the ocean and sees an island. Find PQ, the width of the island. Okay, so we are going to be finding this length here. Well, noticing that that's not attached really into a right triangle, so we are going to have to do like we did for number 2, where we are going to find the entire length, so we can call that X. And then we are going to find this length over here, my Y. And if I subtract those two, that will leave me with this PQ that I'm trying to find. Okay, so with that being said, I'm going to move my angles of depression down here for my angle of elevation. So 27 degrees, and then we'll have that 39 degrees here. Okay, and so I'm going to start off, I'm going to find X first. So I'm going to mark my angle, label my opposite, my hypotenuse, and my adjacent. Okay, so with that being said, I am going to be using tangent here. Sorry, I had to think about that. Tangent of theta, so 27 degrees, is going to be equal to my opposite, 8,000, divided by my adjacent X. Okay, once again, my quick way of solving this one for my calculator ready form is going to be just switching my denominator with my trig function. So X is equal to 8,000 divided by tangent of 27 degrees. Okay, then I'm going to find my Y. So I'm going to be using this 39 degrees. And so I'm going to label my opposite, my hypotenuse, and my adjacent. Okay, and once I've done that, I can see that I'm going to be using that tangent again. So tangent of 39 degrees is equal to my opposite, 8,000, divided by my adjacent, which is that Y. So I'm going to switch my Y and my trig. So I'll get Y is equal to 8,000 divided by tangent of 39 degrees. And so now that I have those two lengths, I can subtract them to find my PQ. Okay, so PQ, we're going to need to start with the largest one, my X. So that's going to be my 8,000 divided by tangent of 27 degrees minus my Y, which is that 8,000 divided by tangent of 39 degrees. And we are measuring in feet. Okay, so that's going to be my PQ answer in calculator ready form. Now let's just plug that in to find the actual length of PQ. Like I said, we're going to round, but to make sure that we have as close to the actual answer as possible, we need to be plugging in this entire thing at once. So we're going to take that 8,000 divided by tangent of 27 minus the 8,000 divided by tangent of 39. And we are going to get 5,821.71 feet. And that is our lesson over angle of elevation and depression.